this video, we're going to take a look at how to code a simple tic-tac-toe game such that we can enter in the number of rows and columns for our tic-tac-toe, and then we should be able to play the game with that many rows and columns. And we should be able to implement our game such that a person can win if they follow any of the normal winning rules for a regular tic-tac-toe game. So if they fill up any row or any column or either of the two diagonals with only their letter, either an X or an O, then that player is going to win. So here, let's just run this solution code. And so we immediately start off with a prompt asking us for the dimensions of the board. So this is just going to be an n by n board. So let's just try this out with 3. So n is 3, which means that we have a 3 by 3 board. Now we start with player 1. So the first player is going to pick their location as a pair of two integers. Now the way we're going to index this is we're going to say that this is at 0, 0, this is at 1, 0, this is at 2, 0, and then this is at 0, 1, 1, 1, and 2, 1, and then 0, 2, 1, 2, and 2, 2. So it's basically the row and then the column, and we're starting at 0 rather than 1, just to keep it simple. So let's say I place an X at the top left corner. That's going to be at 0, 0. And we're going to enter our input just as two numbers separated by spaces. And so we populate that location with an X. Now player 2 can pick some other location. Maybe player 2 is going to pick 2, 1. So that's going to be this spot down here. And then we switch back to player 1. Now let's say player 1 enters some invalid input. So let's say they enter 3, 6. Well, that's not an actual cell. So we're going to get an invalid input error. So we want to enter a valid unoccupied location as an integer pair. So we'll take a look at how we're implementing this. And so then I'm asked once more for the correct location that I want. So maybe I want 1, 2. And so that's going to put X right here. And then maybe player 2 is going to be at 2, 0. And let's say player X isn't really the brightest, so they're going to try and put a location at 2, 0 as well. Well, that's also going to give us an invalid input because that location is already occupied. So let's say the player then puts it at 1, 0. So that'll put an X right here. And then player 2 can obviously place a letter here and they will win. So we can say 2, 2, and player 2 wins and the game is over. And then we're asked if we want a rematch. If we say yes, it will repeat this whole process again. And if we say no, then it will stop the game. So we'll just say no for now. And that ends the entire game. So that's the solution code. That's what it looks like. And that's what we're going to implement in the next few minutes for this video. So let's go ahead and open our template. And the template will be linked in the description. Of course, you don't have to download it. You can just look at whatever we have currently on the screen, and you can just copy it down. So this right here is the template. I've just minimized or folded all of these functions, but let's just open all of them up to see what we have. So before we do that, we have this main function here. This is just going to check if we're actually running this Python as a standalone file and not importing it. Because if we're importing it, then we don't really actually want to play it. We only want to play the game if the Python file is being run itself. So that's the purpose of lines 39 and 40. Now let's go to line 25. That's where the play game function is. Let's open that up. And we're greeted with just some comments and just a print statement. So this is the stuff we're going to fill in. So we already have print n-dimensional tic-tac-toe. That's just the header, the introduction for the game. And so there are a few steps that we have to do to play this game, to implement this. So we have to set up some variables. These are going to include the number of cells we have in each row and column, as well as our board that we're going to use for the tic-tac-toe game. And then we're also going to need two more variables. One is a used variable. So that will indicate the number of cells that we've actually filled up. That'll be important if we want to figure out if we've tied the game. And then the last variable we'll need in this function is the turn function. So that turn function is either going to store a 0 or a 1, and that just indicates which player is currently going to make a move. So once we set up these variables, we need to actually play the game. So this is going to be a loop. And inside this loop, we first want to print the board. We want to show the user what it looks like. And then we want to get the user's pick. So they're going to pick some cell as we saw before. And it's going to be a pair of integers separated by a space. And then once we get that user pick, of course, we need to make sure that it's a valid pick and all of that will be taken care of. and then we need to populate that location. That just means we need to fill that location with either an X or an O based on which player is actually going in this instance. Now after this, we need to check to see if the player that just made a move wins the game. And so that's going to call this function, which we'll go over in just a second. Now, if someone won the game, if this player won the game, then we are going to say that the player won the game. But if there's no win yet, we're going to update to the next user. That basically means we're going to toggle the turn so that we're no longer on player 1, we're on player 2, or vice versa. We're no longer on player 2, we're going to check player 1. Now, outside this loop, if we did indeed get a win, or we got a tie, then we have to do anything that's necessary to finish that game, and then we have to break out of this play game loop. And after this play game loop, we're going to check to see if we need a rematch, if the player wants a rematch. And if they want a rematch, we will call this play function once again. If they don't want a rematch, we'll just end the program there. All right, let's go to the checkWin function. Let's see what this looks like. So here we have a few comments. So the first one is that we want to check the rows to see if the player has won in any of these rows. And then we need to check the columns to see if the player's won in any of those columns. And then we check the left diagonal, that's only one check. And then the right diagonal, that's a second one. And in each of these checks, if there is indeed a row, column, left diagonal, or right diagonal that is fully populated with a single character, that means that a player has won. And in this function, as we'll see later, we won't actually care which player has populated every single row or every single cell in a row or a column or the left diagonal or the right diagonal, because that is kept track of by the turn variable that we will have in this play function. Now at the end, if none of these are going to return true, if none of them have discovered a win, that means we don't have a win. It's either that or we've tied the game. And so in that case, all of that will be taken care of again by the play function, and we can just return whatever is necessary. Now we have a printBoard function, and this takes board as input. That'll just be the board that we are going to use in this game. And so this function is pretty straightforward. We're just going to print what the board looks like, and it's just going to be a simple loop through the entire board. And then we have this getInput function. Now this input function has already been populated, and so we're just opening all this up. So let's just walk through what this is. So we have getInput, and our parameters are prompt, cast, condition, and error message. So prompt is what we're asking the user. Cast is the function or whatever we're doing to convert that input that we get back from the user. So we'll see that we're either going to use this to convert it to integer input or maybe to a tuple input. So then we can get our input for the cell that the player wants to put a character at. And then we also have a condition. This is going to make sure that we actually have valid input. And then we have our error message in case we get a failed condition. Now inside this, on line 3, we have while true, so we're going to keep repeating this. And then we have some error handling that we're doing. So inside the try block, we're going to say val is equal to cast input prompt. Now what we're doing here is we're getting our input with the prompt, and whatever it returns, we're going to execute this cast function on it. So if it's an int, then it's going to say int input prompt. If it's some other function, it'll be some func input prompt. So that'll be returned to val. And once we have that, we need to make sure that a condition is either given to us or that it is not given to us. And if it is given to us, then we need to make sure that that condition is true. So this assert statement tells us whether it's true, but if it's false, it's going to throw an error. And that will lead us into this except clause. And inside the except block, we're going to print our error message or just invalid input in case we didn't give an error message. Now in the event that assert returns true, we are not going to throw any errors, so we will proceed to line 7 and we will just return val. And so that's a sort of complicated way to get our input, but it'll pay off as we'll see later on when we're implementing the play game code. All right, so now that we've walked through all of the code, let's go ahead and start with our simplest function, which is just printing the board. So in this printBoard function, we'll just get rid of pass. So our board is essentially a two-dimensional list. And with a two-dimensional list, what we can do is we can iterate through every row in the board. And for every row, we can just print that row, just expand it out. So for row in board, we will say print asterisk row. And so this just unpacks the row onto the output. And that's all we have to do here. And just to provide for some separation, just to make everything legible, we'll just put a print up here and a print down here, just to separate the board from everything else. And so that's the printBoard function. All right, let's go to the checkWin function. So here, this is going to be a little more complicated. We're going to require a little more algorithmic thinking. So with the rows, we want to go through every row. And for every row in the board, we want to check, did a player win? So the way we can start this is we'll say for row in range, length of board. And inside this, we have to check every pair of columns, every consecutive pair of columns. So that's going to be for call in range, length of board -1, because we have an n by n board. Now, why did we say length of board -1? Well, like I said before, we're checking every consecutive pair of columns. So if two columns are the same, then if we keep checking every two columns that are next to each other, and they're all the same, the entire thing is going to all be of the same element. But then if two of them are different, or if one of them contains an underscore, which is basically going to represent an empty cell, then that means we know that we haven't won. So inside this loop, we'll just put a colon here, and we can say if board row call is equal to an underscore. So that's going to indicate again that we have an empty cell. So if we have an empty cell, then of course the player didn't win at this row. Or maybe the player didn't have an empty cell at this location, but they had it in the next location. It's important to check that. So board row call +1 is equal to underscore. Now, if neither of these are true, then we also want to make sure that these two items are the same. So or board row call is equal to, or not equal to, board row call +1. We're saying not equal to because this is a losing condition. So all of these are losing conditions, and if any of these are true, then this row did not have a winner in it. So we'll just say break, and that'll break out of this loop. So we'll just move to the next row. Now, if we never broke this loop, that means we found a winner. So else, we can return true. All right, so that's it for the rows. Now let's do it for the columns. So the code is very similar for the columns. We'll just say, instead of starting with row, we want to go through every column. So for call in range, length of board. And then here, now we can go through every row per column. So for row in range, length of board -1. And so we check if board row call is equal to underscore or board. Now here we're going to say row +1 because we want to check the next row, not the next column. So board row +1 call is equal to underscore or board row call. So here's where we're going to check to see if, given that these two elements are both populated, we want to see if they're the same. And if they're not the same, then we have a losing condition. So not equal to board row +1, and then just call. And if that's the case, we're going to break like we did before because we have a losing condition. So we want to move to the next column. And if we never broke in this loop, that means we found a winner. So return true. Now we get to the left and right diagonals. So in left diagonal, it's actually a little simpler because we don't have to do a nested loop. Since for a diagonal, we're always going to be comparing board I bracket I with board I +1 and I +1. So the two indices are going to be the same for the row and column. That's for the left diagonal. For the right diagonal, we'll do a little bit of mathematical manipulation to find the column. But let's worry about the left diagonal for now. So we'll say for cell in range, length of board -1. Again, we're doing -1 because we want to compare pairs of cells. So for cell in range, length of board -1, we'll say if board cell is equal to just an underscore, so it's empty, or the next one is empty. So board cell +1, cell +1 is equal to an underscore. And if neither of these are the case, we also want to check if they are the same. And if they're not the same, then we have a losing condition. So or board cell is not equal to board cell +1, cell +1. And if this is the case, we will break, and otherwise, else, we will return true, because that indicates that a player won in the left diagonal. And finally, we need to do the right diagonal. So the code is very similar, but we're going to do a little bit of manipulation to figure out the column, because the column and the row aren't necessarily going to be the same, but we can calculate the column based on the row because we're still in a diagonal. So we'll say for cell in range, length of board -1. So here our condition is going to get a little long, so let's split it up. So we'll say the condition of empty cell is equal to the Boolean value of board cell. And then what is our column going to be? Well, our column is just going to be the opposite end of the board. So len board minus cell, and then we have to say -1. And if this is equal to an underscore, that means it's empty. Now we also have to check the consecutive cell. So that's board cell +1. And then here, we're going to say length of board minus cell -2. And we're saying -2 because if we're going to increase the cell by 1 here, then we have to decrease the cell by 1 here. And we're just saying -1 minus 1 is 2, so we'll just have a -2 here. So if this is equal to an underscore as well, that will be our condition that we check. So this is for the empty cell. Now we also need a condition for difference. So difference meaning that the two cells are different. So different can be equal to the Boolean value of board cell length of board minus cell -1 is not equal to the next cell. So that's +1 and length of board minus cell -2. And then we can check both of these conditions. So if a cell is empty, empty cell, or the two cells are different, so different, then we need to break this loop. So we just break that. And otherwise, we're going to return true because we do have a winner in the right diagonal. And then before we end this, let's just go back to this line right here and just add an or, because we forgot to do that, because it should be either this condition or it should be this second condition. All right, and now that we have this, we've checked the row, the column, the left diagonal, and the right diagonal, and we found no winners. So there's two instances of what could happen. We could either have the case that there were no winners yet, or that the game is tied. And that's not actually a check we need to make in this function. That will be something that we make in the play game function. So here, we can just return false actually. Because if we return false, that means there's no win yet. So essentially what we did in this code block was that we checked to see if there was a winner in the rows, or a winner in the columns, or there was a winner in the left diagonal, or in the right diagonal. And if there were no winners in any of those places, we just returned false. All right, now that we've coded that part out, let's go ahead and code our final function, which is the play game function. And this is the most important one, because it's actually how we're going to play the game. So the first thing is that we have our introduction, just n-dimensional tic-tac-toe. That's already there. And now we need to set up our variables. So let's say n is equal to get input. So n is going to be the dimensions, so an n by n. So maybe you might have a 3 by 3. So get input is going to take in 4 parameters, prompt, and cast, and condition, and error message. And just a quick recap, prompt is the question that we're asking to the user. Cast is going to be what we're casting, or what sort of data that we want to process our input into. And then condition is going to be the condition that our data needs to meet in order to return the proper input. And then the error message is going to be the message that we give the user in the event that they entered the incorrect input. So for the prompt, we can just ask enter n, the dimensions of the board. And so we'll get the dimensions there. And then the data that we get back, we want to cast it to an int. So that's the data processing that we'll do there. So we'll just put int there. And then for the condition, we want to say that for whatever value we have, so we'll say lambda x, for that value, we want to make sure that it is greater than or equal to 3. Because you can't really play tic-tac-toe properly with 1 or 2 cells, or 1 or 2 as n. So we have to say that this x is greater than or equal to 3. And in the event that this is not true, we'll say that our error message is invalid input. Please enter an integer greater than or equal to 3. And so it'll keep asking for proper input until we actually get proper input. Now, once we have n, we need to set up our board. So we'll say board is equal to bracket bracket underscore for, or times n. So that's going to set up a list that has n items, and then for blank in range n. So now we have an actual board of dimensions n by n. Once we have this board, we can create two variables, used is equal to 0 and turn is equal to 0. So what are both of these variables? Well, used is going to be the number of cells that we've used up so far, and turn is going to be the current player that we're on. So 0 indicates that we are on player 1, and 1 indicates that we're on player 2. So the next part is to actually play this game. So this is going to require a loop. So we'll say while true. Now first we want to print the board. So we'll say print board, and that's just going to be board. And so that just tells the user what the board currently looks like. Now after this, we need to get the user's pick. We want to see what they pick for their input. So we can say pick is equal to get input, and then we need prompt equals something, and then we need a cast is equal to something, we need condition equals something, and we need error message is equal to something. So our prompt is going to be, I'm just going to put an F here to make it an F string, and we'll see why in a second, player turn +1, and then just a dash, and then pick location, row, and column. So that just indicates to the user what their input should look like. And we're making this an F string just so then we can add in this data right here. Now the next part is our cast. So our cast is going to be a little bit complicated. We want to convert our string input of 2 characters or 2 integers separated by a space into a tuple of 2 integers. So we're going to say lambda line. So line is going to be the line that we get from input. And then if you've seen another video that I've posted on YouTube, it's about how to get integer input and convert it into a list. Well, we're going to do the exact same thing here, but we're going to convert it into a tuple. So we'll say tuple map int line.split at spaces. So here, a quick recap of what this does. This is just going to split the string at a space. It's going to return in a list. And then we want to convert every item in the list to an integer using this map function. And then that's going to return a generator object of those 2 integers, and we'll just convert it into a tuple. Now, once we've casted the data to look like what we want, we need to make sure that both of those numbers are actually within the proper bounds, and that the location that the user has given has not already been populated. So the condition is going to be lambda pair. So that's the pair that we're getting from that get input. And so for this pair, we want to check that the minimum of the pair, so the minimum of the 2 coordinates, is greater than or equal to 0, and the maximum of the 2 coordinates is less than n. That makes sure that both are actually between those 2 bounds. And then in addition to this, we want to make sure that the place is not currently populated. So we'll say board pair 0, pair 1, so that's row and column, is equal to underscore. If it's equal to underscore, then it's not populated. Otherwise, it is populated. And our error message will be invalid input. Please enter a valid, unoccupied location as an integer pair. And so that's our error message. And after we've gotten our user pick, we need to increment used by 1 because now we've actually used another cell. And so the part where we use that cell is going to be in populate location. So it's actually probably better if we move this used under this tag. So use plus equals 1, and then above this we'll say board pick 0 at pick 1. So that's our tuple row and column. And this item is going to be equal to x if the turn is equal to 0. And if it's not equal to 0, then it's going to be an O, because that means we're on player 2, not 1. And then line 80, we have to increment used by 1. And then after that, we need to check to see if there has been a win. And so that is through the checkWin function that we've already implemented above here on line 19. And so we can go back here and we can say if checkWin board. So if there was a victory, then we say print board and we provide the board as our input. And then we can just say print, and we'll make this an F string because we're going to put some items into our template. And we'll say game over, player turn +1 wins. And then we can break out of this loop, out of this entire play game loop. Now, if we didn't win, then we also need to make sure that we haven't tied the game. So check for tie. Now, how do we check for a tie? Well, that's where used is going to become important. So if used is equal to, elif used is equal to n times n. That means we've used up all the cells, so we can say print board, and we'll say print game over, players have tied the match. And then we'll just break out of this loop as well, because there's nothing more to play in this game. Now, otherwise, there's nothing that we actually need to do, so all we need to do is update for the next user. So we'll just say turn is equal to turn plus 1 mod 2. So that'll make it so that we're always switching between 0 and 1 for our turns. So it'll be 0, 1, 0, 1, 0, 1, etc., etc. Now, after this loop, after we've played our game, we need to check to see if we want a rematch. So these code blocks right here, these segments are going to break out of our loop. And so after we've broken out of the loop, we need to check if the player wants a rematch. So we'll say play again, and then again we're going to use this get input function. So play again is going to be a Boolean value, or it's actually going to be a string. So play again is going to be equal to get input, and we'll say prompt is equal to something, cast equal to something, condition is equal to something, and error message is equal to something. So our prompt is going to be rematch, and then we'll just say y/n. So our two responses that we're expecting are either going to be y or they're going to be n. And so we'll put a space there just to provide some space for the user to type. And then our cast is just going to be a string. We just want to convert this to a string. Even better, we don't have to convert it to anything, but if we look at our function header, our default value was going to be a none for the cast. So we do want to provide something. So if we provide string as our function, it's not going to change anything. So for our condition, we want to say lambda ans. That's just going to be the answer that we get from the user. And if the answer is a yes or a no, then it's valid input. Otherwise, it's not valid input. So ans.strip at a new line, that's just going to be because we might get a new line character at the end. And so this dot lowercase, because the user might enter uppercase, if this is in the set of yes or no. And so that's our condition. And if we don't meet that condition, then our assertion is going to throw an error, and our error message is going to be invalid input. Please enter y or n. And then we can just close this off. And so that's play again. So play again is going to be y or n. Now we check if play again is equal to n. That means we need to end the game. So we print, we'll just put a new line here, game ended. And then we'll just return. And so this right here should be inside this function, inside this if statement. Now, otherwise, we will play this game again. So that'll be a rematch. And so we'll just call the play function. And that will recursively play this game over again. And so that's it for this code. So let's just quickly recap what we did here. So at the top, we had our get input function. That just helps us get input for various instances. And then after that, we created a function to print the contents of the board. And then after that, we check to see if the player won. So there are a few conditions to check. We want to check all the rows, all the columns, the left diagonal, and the right diagonal. And otherwise, no player has won yet. And then we incorporated our main play function. So here we got our variables that we needed, and then we played the game. We kept getting user input. We populated the required locations. We checked to see if any player won. And we also checked to see if there was a tie. If no win was there, we updated for the next user. And otherwise, if there was a win, we broke out of that loop and asked to see if there was a rematch that the player wanted to do. So let's go ahead and test out our code. So run this and let's play a 3x3 game. So n is 3. Now, let's say the first player plays 0, 0. All right, now the second player might play 0, 1. Let's say we want to test to see if the diagonal works. So we'll say that player 1 plays 1, 1. And now let's say player 2 very gullibly plays 2, 0. And finally, player 1 can win by playing 2, 2. And we see that player 1 wins and game over. And so we're presented with this option, do we want a rematch? Let's say that we do. And this time, let's say that we have a 4x4. So now we have 4 items here. So let's let player 1 win again. So we'll put player 1 at the opposite diagonal. So let's say we check for 0, 4, or 0, 3 actually. So that'll populate the character here. And let's say player 2 is still a little bit gullible and doesn't really understand the rules of the game and enters some really large numbers for their location, so 20 and 20. Well, we're going to get an invalid input. So looks like our code worked there. And let's enter something that actually works. So maybe 1, 1. So now O is right here. And let's put an X right here. So that's going to be at 1, 2. And so we've put our X here. And now let's put O somewhere else, so maybe at 0, 0. So we've put the O here, and now we want to put an X here. That's going to be at 2, 1. So we've gotten our X, and let's put an O right here. So we'll put 2, 2. And finally, let's end the game for player 1 by placing an X at 3, 0. And so that ends the game, player 1 wins. And we can just say no if we don't want a rematch, and the game has ended. So that's it for this video, and I hope this tutorial on creating a tic-tac-toe game was helpful.